All right, continuing on with 12.4, adding and subtracting rational expressions. Um, we see an addition of rational expressions here, and I need to find a common denominator. I have this binomial x plus 4 and this binomial x minus 2 here. And what we learned in 12.3 was that our common denominator is going to be x plus 4, x minus 2. Then we still have our plus sign, and the common denominator is going to be x plus 4, x minus 2. Okay, so both binomials have to be represented in the common denominator. So again, like the last video, I kind of asked myself, okay, what did I multiply by to get to this denominator? And what I multiplied by was x minus 2. And I'm going to just show this up here that I multiplied this by x minus 2. So I'm going to have to multiply this numerator by x minus 2 also. And then on this side, the second expression here, rational expression, I multiply by x plus 4. And so I'm going to show that over on my second rational expression. Now, if you look here, if you look at this and think about it, when you have x plus 4 over x plus 4 and x minus 2 over x minus 2, that's a disguised version of 1. The value of that is 1. So I'm really multiplying this fraction by a various form of 1, okay? Just to get it so I can combine these like terms with the common denominator, okay? Now, if you spot in this numerator here, this is a conjugate pair, so we know we just have to multiply x times x, and we get x squared. And then we take negative 2 times 2, we get negative 4. And then over here, I might want to put my parentheses on to help me. Again, it's conjugate pairs, so I have x squared, and then 4 times 4 is 16. I get negative 16. Okay? So working with the numerators, I have x squared plus x squared is 2x squared, and negative 4 and negative 16 is negative 20. And then I have over x plus 4, x minus 2. Okay? Now, some student might have said, well, should I factor that? Should I factor that numerator? And you could. That numerator would factor into 2 times x squared minus 10 over x plus 4, x minus 2. But you know what? That doesn't help us any. We can't factor this any further, and there's nothing that will cancel out. So you could write it in either form, that'd be fine, but we could have probably stopped at this form. Either form is okay. All right. So now taking a look at D here. Let me just fold my paper here. So taking a look at well, I guess it's letter E. That was D, the last one that we did. So looking at E, we got to get a common denominator. What we're going to do first here is we're going to factor this to be x minus or x plus 2, x minus 1, because when this is factored, okay, then this is factored, we can see the binomials that we need. Okay, so this first one, it has an x plus 2, but I'm putting the new binomial of x minus 1 on it. Then I have my minus sign. I have 5x minus 16. And then this denominator actually has all the binomials in it. So it was just this first expression that rational expression that we changed. We multiplied by x minus 1 to get our common denominator. So I'm going to multiply by x minus 1 here. I'm just kind of writing it up top. So I use the distributive property. I get negative 2x plus 2. Be careful with your signs there. And likewise, be careful with your signs here. Okay? Remember that this subtraction can be changed to add the opposite, but you have to remember to change that sign right here also. So add the opposite. So now we can see the terms we need to collect up in the numerator. We have negative 7x 2 and 16 make 18. And then we have over x plus 2, x minus 1. Okay, we're not getting too many of these that, in fact, we haven't gotten one yet that simplifies at the end. But you got to be careful. If you can simplify this or reduce this, you would have to factor and then cancel out things. All right, so be careful with that as you work through 12.4. If you type your answer in and it says not in simplest form, then you would have to try to factor and simplify. Okay. So looking at this last one here, F, I spot the binomial x plus 6 and the binomial x minus 7. And it's a subtraction problem, so I need a common denominator. So I'm going to write down x plus 6, x minus 7. Setting this nicely up so I can make my common denominator or my common fractions. Okay, so this one had the x plus 6, so the new piece is x minus 7. So I'm going to write that up next to this. Kind of cram it in there. And the new piece on this fraction on the right side is x plus 6. So I have to multiply by x plus 6. So what you see again is another conjugate pairs problem. We get x squared minus 49 by the FOIL, or by F times L for conjugate pairs. And then we have x times x is x squared. Negative 6 times 6 is negative 36. Okay? So very similar to letter D that we did. So here I'm going to change this to plus, minus, plus, because of the subtraction. And I end up with, well, the x squareds cancel out, and I have negative 13 over x plus 6, x minus 7. Okay. I just want to show you one more thing in this video. It's not on the worksheet, but I did want to show you that if you would say you would work out a problem, you know, you have a fraction, a rational expression, plus a rational expression, okay, and we work this problem out, we do all the work, and let's say we ended with x squared minus 3x minus 10 over x plus 2x minus 5. Okay, so that was our answer, and we thought, great, that's our answer, and we typed that in to the Huck system, and it says your answer is not in the simplest form. Okay, well, that's because in previous I think it's 12.2, we learned that if we have a rational expression like this, that we should try to simplify it and write it in simplest form, and the top of this would factor into this. Okay, and the bottom, if we look, is x plus 2, x minus 5. Well, we look, hey, that cancels out, that cancels out, all that stuff cancels out, and it was actually equal to 1 in simplest form. So sometimes a lot of stuff will cancel out, and it's hidden in the depths of the problem, and you have to factor it before you can find that. Okay, so be prepared in 12.4 to have to simplify your answer at the end by the methods you learned previously. Okay, all right, well, that wraps up 12.4. Make sure to contact me if you need some more examples. Thanks.